Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 6, Lesson 7 on quadratic inequalities in one variable. Well, that is a mouthful, let me tell you. Now, you've obviously had a lot of experience solving equations, and in the last lesson, we reviewed how to use the zero product law to help us solve quadratic equations, in other words, equations that contain an x squared in them. Today what we're going to do is we're going to replace the equation with an inequality, a greater than, less than, etc. But before we get into the algebraic techniques on how to solve these more complicated inequalities, let's first make sure you understand what it means to solve an inequality, or better yet, to have a solution to an inequality. And we'll do that in the first exercise. Okay, exercise 1. Determine if each of the following is a solution to the inequality given. Show work to justify your response. So in other words, in letter A, we've got the inequality x squared minus 3x minus 10 is greater than 0. And I want to know whether or not x equals 4 is a solution to that inequality. All right, so what do you think? How do I check this? Well, hopefully, what you remember from Algebra 1 is that whether you're talking about an equation or an inequality is completely irrelevant. What's important is that when you substitute that value into that expression, does it make it true? Well, let's take a look. We're going to get 16 minus 12 minus 10 is greater than 0. 16 minus 12 is equal to 4. And 4 minus 10 is negative 6. Negative 6 greater than 0? No. That's false. So therefore, that is not a solution to the inequality. Now that's really, really important. It is really critical that you understand that all a solution to an inequality is something that makes that inequality true. And negative 6 ain't greater than 0. Therefore, x equals 4 is not a solution to the inequality. Why don't you pause the video now? Even if you need to use your calculator, that's okay. But go ahead and work through these to see if x equals 2 is a solution to the inequality in letter B, and x equals negative 3 is a solution to the inequality in letter C. All right, let's go through them. Now again, the actual arithmetic isn't all that interesting, but I am going to show the initial substitution, even if I'm not going to show all the arithmetic worked out. Because again, this is the idea. Is this true or is it false? If it's true, x equals 2 is a good solution, and if it's false, it's not a solution. When you work all of that out, what you find is that it's equal to 27. And is 27 greater than or equal to 0? Well, yeah, sure it is. That's true. So the answer here is yes. That is the solution to the inequality. That's simple, really. Very, 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 very important. Now, if you put negative 3 into this one, negative 3 squared minus negative 3 minus 12 is less than 0, and you evaluate all of this, what you find is 0. Now, this can throw students off. 0 is less than 0. Well, is it? And the answer is no, it's not, right? That's a false statement. A number cannot be less than itself. It can't be greater than itself. That's false. And therefore, the answer is no. Right? That is not a solution to this inequality. Okay? Now, again, before we move on, it is really critical for you to understand that, all right? Because we're going to be doing a lot of these checks eventually. So pause the video now and write down anything you need to. Okay, clearing out the text. And I think we're also going to change ourselves back to blue. I like blue. All right. Let's jump in and try to solve an inequality. Exercise 3 says, consider the quadratic inequality x squared plus 2x minus 3 is less than 0. Letter A says, solve the corresponding equation. Notice these two are very, very similar, except instead of a less than, we have an equality. Algebraically, for all values of x. So why don't you pause the video and really quickly solve that equation. All right, well, this requires the zero product law, but, at least it's already equal to 0. We can factor this thing, and x, and I believe it's a plus 3, and it's a minus 1. So we have x plus 3 equals 0, and x equals negative 3, and we have x minus 1 equals 0, and x equals positive 1. All right, there we go. Now letter B says, using your calculator and the equation y equals x squared plus 2x minus 3, fill in the table below. All right, so you should know how to generate a table on your calculator. Pause the video now and fill that table in, assuming that you put the x squared plus 2x minus 3 in as your y1. Okay, well, I'm not going to open up the TI-84 Plus right now. I might open it up a little bit later, but we've done tables many, many times. So here's what you end up seeing. All right, it's parabola, so nice and symmetric. By the way, note, something that we should have already known, when x was negative 3, y was 0, right? That corresponds to this guy. And when x was 1, y was also equal to 0. That corresponded to this thing. Now, letter C says, explain why the zeros you found in part A, right, are not part of the solution set of this inequality. So why are negative 3 and positive 1 not part of this solution to that inequality? Think about this for a little bit. Okay, well, hopefully you have it. Whoops, random red line. That's where I draw the line. All right, but this is why. Those values make the expression x squared plus 2x minus 3 equal to 0. But we want values that make it less than 0. Right? It's as simple as that. Those two values of x are going to make that trinomial have a value equal to 0. But we want all the values of x that make that expression less than 0. All right? Now, letter D says, write the solution set of the inequality and represent it on a number line. I think I'm going to actually get rid of my red line here. Random red line. So let's talk about that. We want all the values of x that make the value of this expression less than 0, negative. Well, take a look at this table. Right? Everywhere in here, it's negative. Now, a lot of students might say, oh, okay, then this should be my solution, right? Negative 2 to 0. But actually, our solution is going to extend from negative 3 all the way to 1. It's just not going to include the negative 3 or the 1. Because at negative 2.5, the expression is negative. At negative 2.9, the expression is negative. The expression is really negative everywhere from 3 to 1. It just isn't negative at 1, and it isn't negative at 3. And then it goes positive, right? So it's negative out here, and it's positive out here. So on a number line, what we would see is the following. We'd see our negative 3 and our positive 1. These would be represented as open circles because they are not included in the solution set. And then we would poorly color in the number line between the two. Sorry about that. But that would be our solution. Now, this particular exercise doesn't really walk you through necessarily a method for finding the solutions, although you could make the argument that just using that table is a good way to get the solutions to this inequality. All right, but we are going to take a look in a moment at sort of a more general method, and we'll look at it first with a multiple choice problem. Pause the video now, though, and copy down anything you need to. Okay, clearing it up. Okay, exercise 3. Which of the following is the solution set of the inequality x squared minus 4 is greater than 0? All right. Well, let me just lay out steps. All right. What I do to solve every inequality algebraically is I first take that inequality and I change it into an equality, and I solve it. Now this one's actually pretty easy to solve. We're going to have x minus 2, x plus 2 gives me x equals 2, gives me x equals negative 2. All right. The next thing I'm going to do is I'm going to plot those on a number line, negative 2, positive 2. I then will decide whether I should have open circles or closed circles. Now, because there is no inequality, there's no equal sign on that inequality, these two are open circles. All right, no big deal there. Just kind of get rid of that a little bit. And now what I do is I test points. So I grab a value of x out here. Let me take x equals negative 3. And I see if it works in the inequality. Let's check that. Negative 3 squared minus 4 is greater than 0. Is negative 3 a solution? 9 minus 4 is greater than 0. 5 is greater than 0. Yes, that's true. Okay, so everywhere out here, my inequality is solved. Everywhere out here. I am having a hard time drawing these things today. That is a terrible looking arrow. Maybe I'll draw it in a different color next time. All right, let me pick a value of x in here. X equals 0 is an excellent choice. Let me go with that. 0 squared minus 4 is greater than 0. 0 minus 4 is greater than 0. Negative 4 is greater than 0. That's false, so I'm not going to color it in there. Let me pick something out here. Why not? Let me go with x equals 4. So let me do 4 squared minus 4 is greater than 0. 16 minus 4 is greater than 0. Let's try that. As 12 is greater than 0, and that's true. True. Switching over to red, because I've hopefully learned my lesson. There's my inequality. Now, what's my final answer? Well, my final answer is all values of x that are less than negative 2 or greater than positive 2. And that's choice 3. All right. Not too bad. I know that it looks like a lot of work, but you'll get the hang of these pretty quickly. So pause the video now, copy down anything you need to, and then we'll go through quite a few exercises. Okay, I'm going to clear this out, and let's get some practice. You end up solving a lot of inequalities as you go on in math, and they can come in a variety of different forms. Linear inequalities, which you worked a lot with in Common Core Algebra 1, are very easy because they basically follow the same sort of rules that equations do in terms of manipulating them, with that weird exception that if you divide by a negative or multiply by a negative, you have to flip-flop the inequality sign. But all other inequalities besides linear really are solved in the same way. All right? Step 1, if you will, take the inequality and change it into an equation. Step 2, solve that equation. All right, in this case, 9, 4, negative, positive. I'll get x equals 9, x equals negative 4. Third step, draw out a number line. Plot your points, negative 4 and 9. Decide whether or not there should be sort of closed circles or open circles. On here, because there's an equality, these two things are solutions. So I'm going to put a filled in dots there. All right, and then test values. Let me get rid of this. So for instance, if I test x equals negative 5, and again, I'd probably use my calculator on this. I plug negative 5 in there. What I would get is I'd get 14 is less than or equal to 0, and that's false. So I'll put a little f up here. All right, maybe I'll test something in between, like x equals 0. If I put that in there, I'd get negative 36 is less than or equal to 0. That's certainly true. Then maybe I'd take, let's say, x equals 10, and I'd plug it in there. And what I find with 10 is, again, 14. That's due to the symmetry of the parabola. 14 is less than or equal to 0. That's false. So now I color in where it's true. And again, I sort of learn my lesson. And I get that. My final answer now is negative 4 less than or equal to x less than or equal to 9. Since they said put it in set builder notation, I got to have the fancy curly brackets around it. and that's it. Okay. Again, a lot of that sort of checking work, when you check the three values of x, can be done using your calculator, no question about it. All right, and in fact, I'd advise using it to save yourself a little bit of time. Okay. Let's do one together that's a little bit more complicated, only because the factoring is harder. Right? Same idea. I'll take my inequality and I'll change it into an equation. Now, I'm not going to sit around and make multiple incorrect guesses because that would just waste our time. But let's verify. We'd have negative 2x and positive 30x. That'd be positive 28. And then when I solve, I'll get x equals 2/5 and x equals negative 6. All right, let me put my negative 6 on and let me put my 2/5. Open circles or closed circles? What do you think? Open circles, right? Because the less than does not have an equal on it. So open circles, maybe I'll put those in red in a little bit. And now I'm going to start testing points. So for instance, if I tested x equals negative 7, if I threw it in all of that, I'd have 37 is greater than 0. And that would be true, right? Then maybe I would test, I love testing x equals 0 when I can. That would give me negative 12 is greater than 0, and that's false. And then maybe I'd take x equals positive 1, right? That's bigger than 2/5. And I'd throw it in all of that, and I'd get 21 is greater than 0, and that's true. So my solutions now in red look like this, right? And my final answer is all values of x such that x is less than negative 6, or, not and, x is greater than 2/5, or not and. That's it. So it's not that bad. You know, again, it's definitely more complicated than solving a quadratic equation. And in fact, in order to do these, we have to solve a quadratic equation. But once we get done with that, then we plot our solutions on the number line. Now, a little explanation. The reason that this works is that equality, something with an equal sign, is, if you will, the boundary between greater than and less than. So if an expression, right, that's what we've got expressions on the left-hand side. If that expression is going to change from being positive to negative or negative to positive, it's got to do it at an x value where the expression is equal to 0. All right? You can't go from negative 5 degrees Fahrenheit to positive 7 degrees Fahrenheit without going through where the temperature is equal to 0. And that's the same case here. That's why we solve the equation first. All right? And in fact, right, if we look at ones that are more complicated, it's still not too bad. Now, good question. Should I change it into an equation first? Or should I manipulate the inequality, then change it into an equation? The good news is it doesn't matter. I like, if possible, to always have my inequalities compared to 0. So, oh, look at that, negative 8, positive 8, those cancel. So to me, what I like to do is I like to change it into an inequality that's compared to 0 before I change it into an equation. So once I have that, I'm now going to set it equal to 0, right? Then I'm going to factor out that 2x, right? 0 product law always. Then I'm going to get 2x is equal to 0, divide both sides by 2, I'll get x equals 0. X minus 7 equals 0, x is equal to 7. So I'll draw out a number line now. On that number line I'll have 0, and I'll have 7. And now I have to test some points. And I'm going to test them in this inequality, because again, to me it's easier. So like if I took negative 1 and I threw it in there, what I'd end up having would be, yeah, a positive 16. Greater than or equal to 0? Yeah, that's true. Oh, I never figured out closed circle, open circle. Let me go in red. These are both closed circles, right? Because the x values are included due to the inequality. or sorry, due to the equals sign on the inequality. Now, what would I want to do in between? Well, x equals 1 is not a bad choice. It's between 0 and 7. If I put x equals 1 in there, I'd get negative 12 is greater than or equal to 0, and that's false. Finally, if I took x equals 8 and I substituted in, sorry, I'm running out of room here, and I have to keep looking down at what I was getting in the evaluation, I'd get 16 is greater than or equal to 0. That's true again. So that means my solution set looks something like that. And let me write it in red so it really stands out. X is less than or equal to 0, or x is greater than or equal to 7. All right. Why don't you give a shot to the last one, letter D. We've done a number of these together. See if you can do letter D on your own. Okay, let's tackle it. Again, before I ever get this thing, set this thing equal to 0, I'm going to manipulate the inequality. So I'm going to leave the inequality the way it is. Here I'll have x squared. Oh, these two cancel. That's cool. Negative 6 minus 9 is, whoops, that's not a 9, that's a 19. I knew something funny was going on. I figured I'd have the difference of perfect squares, and I'm like, no, I don't think 15 is perfect square. Here we go. X squared minus 25 is less than 0. So I'm going to make that into x squared minus 25 is equal to 0. Solve. We'll get x minus 5 and x plus 5, and x equals 5 and x equals negative 5. So we put our negative 5 down, our positive 5 down. Test some points. Let me try x equals negative 6. If I substitute that in here, right, I'd get, I think 11 is less than 0. That's going to be a false. If I test x equals 0, I'd get negative 25 is less than 0. That's definitely a true. If I test x equals positive 6, I'll get 11 is less than 0. That's a false. Let me do all my coloring. Open circles on those two, and color in between. Our solution is all values of x such that negative 5 is less than x is less than 5. All right. Whew. Man, my hand hurts after all of that. That's a lot of writing on the screen. So pause the video now, take a look at what we did, and write down anything you need to. All right, let me clear out the text. I hope you got that all. Okay, you can always rewind the video. Let's take a look at a couple of multiple choice questions on this. So, one thing that we can do when we look at this, it says the number line graph is the solution to which of the following inequalities? Well, that's tough because I don't want to go about solving every one of these inequalities. Think about that. That's 4 inequalities. I don't want to do that. Are there any that we can eliminate by simply looking at the number line? I want you to think about this a little bit. All right. Well, the answer is definitely yes. We can eliminate this and we can eliminate this. Based on the fact that we've got closed circles here, there's got to be the equality. So it's got to be one of these two. Now, let's just take a look at the equivalent equations. X squared minus 2x minus 8 is equal to 0, and x squared plus 2x minus 8 is equal to 0, right? And let's solve them. Here I'm going to have x minus 4 and x plus 2. That'll give me x equals 4 and x equals negative 2. This one, on the other hand, when I solve, right, it factors a little bit differently. All right, so if we were just to do the first step in the inequality, right, what we'd have is we'd have a negative 2, we'd have a positive 4, and it'd look like this. This one, on the other hand, would have a negative 4 and a positive 2. It would look like that. So this has got to be our winner, right? I'm not going to even do the rest of the testing. This value of x, this value of x, this value of x, all right? Just based on the fact that the zeros of the expression itself are the -4 and the 2, I can get down to choice 4. All right, pause the video and think about that a little bit. Okay, clearing out the text. Okay, final problem. Which of the following represents the solution set of this inequality? Now, there's a lot of different ways to do this. Let me show you how to do it algebraically. Okay? -2x squared plus 7x minus 3 is greater than 0. Well, the first thing I'll do, since it's already compared to 0, is I will turn that thing into an equation. Okay? Now, I don't know about you, but when the leading coefficient on an equation, a quadratic equation, is negative, to me, I have a much harder time factoring it. So what I'm going to do is I'm going to divide both of the sides of this equation by -1. Now, the effect that's going to have is it's going to make the -2x squared into a positive. But remember, we have to distribute division, so that 7x is going to become a -7x. And that -3 is going to become a +3, right? So now I do something like this. And is that right? Let's see. -x, -6x, -7x. Yep. And we get 1/2 and 3. All right, great. Well, that actually allows us to eliminate a few answers immediately, by the way. It means this one's out and this one's out, right? It's got to be either choice 1 or choice 4. This is where I can start to put things down like this. Now, I should be careful. I need to test in here. So let's test x equals 0. If I put 0 into this expression, I'll get -3 is greater than 0. No, that's false. If I put x equals 4 in, all right, what would I get? I'd get 16, -32, 28, -4, -7. Well, that can't be right. Let's see. What happens if I put 4 in? I didn't work this one out, which is a little weird. Why is that not working? Oh, I know why it's not working. Sometimes I make mistakes. Actually, often I make mistakes. Do you see what mistake I'm making? Because here I'm trying 4, and I'm getting -7 is greater than 0, and that's also false, right? So we're false out here. And what was throwing me out is I'm not used to having a false and a false. But here's my problem. 0 doesn't lie between 1/2 and 3. So it doesn't mean that that thing is worthless. It actually just means that I tested a point now out here. So it's also false. Let's do one that actually lies in the middle. Like, I don't know, x equals 1. When we put 1 in, what I'll get is -2 plus 7, which is 5 minus 3, 2. And I'll get this, and that's true. I'm so worried. Actually, I was kind of excited. I thought something really cool was happening. Now, by the way, these are obviously open circles. And now I'm going to actually color it in blue to give myself that contrast. This, then, is my solution set. And that turns out to be choice 1. Wow, sorry about that. Got very confused all of a sudden. But again, I think it's good to make mistakes in math. I mean, that's what math is all about. That's what problem solving is all about. So when I make a mistake, what I don't necessarily want to do is go back and edit it out so you think that I've got all the answers or so that I never make a mistake. Trust me, your math teachers make mistakes just like I do, just like everyone does. Don't be afraid to make the mistakes, learn from them, and keep moving on. All right, pause the video now and write down anything you need to. All right, let's clear it out. Man, that was weird. Okay, so today what we did is we looked at how to solve a higher order inequality. The only type of inequalities you have ever solved are linear. But for those of you that go into pre-calculus and calculus, you'll solve all sorts of inequalities all the time. And eventually what you'll find is that they're all basically solved the way we just solved quadratic inequalities. In other words, you take the inequality, you change it into an equality, and you solve. Those values, right, are sort of, if you will, your switchover points. They're where you can go from greater than or less than. So you plot those on a number line. Sometimes those values are called critical values. You plot them on a number line. You test various values, and you then find your solution set. All right. We'll see some other higher order inequalities as we move through this course, but quadratics are the first one we saw. Okay. Thank you for joining me, though, for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.